Upcoming chapters will introduce a variety of techniques for describing data and transforming the data into information. As you'll see in those chapters, the statistical techniques deal with different types of data. The level of measurement may vary greatly from application to application, but in general there are four types of data: quantitative, qualitative, time series, and cross-sectional. Quantitative data are measurements whose values are inherently numerical, such as dollars, pounds, inches, or percentages. In other situations, the observation may signify only the category to which an item belongs. Categorical data are referred to as qualitative data. In statistics, quantitative data is the most powerful, but in many instances, qualitative data is the only option. Data may also be classified as either being time series or cross-sectional. Time series data is the set of consecutive data values observed at successive points in time. An example of this would be the stock price as a function of time. With time series data, it is extremely important to keep the data in order. Cross-sectional is a set of data values observed at a fixed point in time. We can see on this slide how data can be both time series by sales per year and cross-sectional by city in a given year. Next semester, we will devote a couple of chapters to studying and analyzing time series data. Data can also be identified by their level of measurement. This is important because the higher the data level, the more sophisticated the analysis that can be performed. This is clear when you study the material in the remaining chapters of this text. Nominal data are the lowest forms of data, yet you will encounter this type of data many times. Assigning codes to categories generates nominal data. For example, a survey question that asks for marital status provides the following responses: 1. Married. 2. Single. Performing a numerical analysis such as averaging provides little to no value. Counting and graphing is about the best thing you can do. Ordinal and ranked data are one notch above nominal data on the measurement hierarchy. At this level, the data elements can be rank ordered on the basis of some relationship among them, with the assigned values indicating this order. Ordinal measurement allows decision makers to equate two or more observations or to rank order the observations. In contrast, nominal data can only be compared for equality. You cannot order nominal measurements. Thus, a primary difference between ordinal and nominal data is that the ordinal data can have both an equality and a greater than or less than relationship, whereas nominal data can only have an equality relationship. If the distance between the two data items can be measured on some scale and the data have ordinal properties, the data is said to be interval data. The best example of interval data is temperature scale. Both the Fahrenheit and Celsius temperature scales have ordinal properties. In addition, the distance between equally spaced points are preserved. For example, the difference between a 32 degree and a 30 degree Fahrenheit is the same difference between 80 and 78 degrees, 2 degrees in each case. Thus, interval data has allowed us to precisely measure the difference between any two values. With ordinal data, this is not possible, because all we can say is that one value is larger than another. Data that have all the characteristics of interval data but have a true zero point are called ratio data. Ratio measurement is the highest level of measurement. This slide is a good example of how data can be categorized. In the next set of videos, we will dive into describing data with graphs, charts, and tables.